Hello and welcome to another episode of the Women Developer Academy Speaker Series. For the past 6 weeks plus, we have had amazing Women Tech Makers ambassadors joining us to share insights about various technical topics from Android, machine learning, Google Cloud, and even web technologies. And so much more has been shared on this platform. Today, we are going to be joined by Velda Kiara, who is a Women Tech Makers ambassador, a participant of the Women Developer Academy, and a seasoned software engineer. I'm going to hand it over to her to take us over. It all works on all machines with Kubernetes. Sorry, with Docker. Over to you,
Awesome.
Velda. Okay.
Thank you for the introduction, Amila. So yeah, I'm also a software engineer and technical writer, and today we're going to talk about it works on all machines. So the agenda of the day is looking at how to containerize your application. In this case, will be how to containerize a Django application. We're also going to look at the differences between Docker and Kubernetes, and also how to deploy to Kubernetes. So the first thing that we're going to look at is containers. So what are containers? So containers are standalone executable packages that contain tools needed to run the software consistently across environments, regardless of infrastructure. So that's the main thing about containers. It's basically having an application that can run on any particular environment, which solves the issue of it only works on my machine. So with a container, the application can work on multiple devices, not just your machine. And then the differences between containers and VMs is that VMs and containers both offer isolation for running application, but they are also very different. VMs emulate physical computers, including the operating systems, because they also run on a hypervisor, which is basically a software or hardware that creates and runs the virtual machines. And then containers, on the other hand, they share the operating system kernel and are also isolated processes, but they're much lighter than VMs because they can easily start and stop quickly. And I would highly advocate to use containers as compared to VMs. And then containers are also portable and consistent since they eliminate the issues of operating systems incompatibilities. And then in regards to isolation and resource efficiency, containers provide a level of isolation for applications by encapsulating them within their own runtime environment. So you don't have to worry about the underlying architecture. And then containers achieve isolation through features like namespaces and control groups. And then, in regards to also resource efficiency, it is a significant advantage of containers since they share the same OS kernel. So, moving on to the next thing that we're going to talk about is Docker. So, we're going to look at what Docker is, the key concepts, and the benefits. So, Docker is an open source platform for developing, shipping, and running applications in containers. It allows developers to run consistently across different environments. The key concepts on Docker is the Docker images, which are read only templates that define the contents, configuration, runtime environments, and also configuration. And they also act as building blocks for the containers. And then the next thing you need to know is images. And then a Docker file, which is something Docker images, kind of like GitHub, but now for containers. And then another thing you is advantageous to know is on orchestration. So Docker has Docker Swarm and Kubernetes, which are tools for orchestrating and managing containers in production environments. And then a few benefits of why you'd like to use Docker is because of portability, because Docker containers are portable across different environments. There's also efficiency because it's lightweight and it shares the OS kernel. And then we also have scalability since the containers can easily be scaled up or down to meet the current demands. The next thing is how the architecture of Docker looks like. So first things first, we have the Docker client. So the Docker client is the primary interface which users interact with Docker first. It accepts commands from the users and communicates them to the Docker daemon. So the Docker daemon is also known as the Docker engine. It provides a background service which is responsible for managing Docker containers, and it listens for requests from the Docker client via the Docker API, which carries out the building, running, and monitoring containers. And then Docker registry basically stores Docker images, and it's a repository for Docker images, which is similar to version control, as I mentioned, like GitHub. And you can easily set up private registries or even public registries. Um, the next thing is to look at how does Docker work. So as I mentioned before, we have the Docker client, which is Docker uses a client server model. So Docker operates on a client server architecture, which means a user interface accepts commands from users, and then it communicates this particular command to the Docker daemon, which does the heavy lifting. We also have the Docker CLI, which is the command line interface, which allows users to interact with the Docker daemon and provides a set of commands for tasks such as building Docker images, running, and managing containers. And then we have the Docker API. So the Docker daemon actually exposes a RESTful API that the Docker CLI interacts with, which allows other tools and services to connect to Docker daemon programmatically. The last thing is Docker engine, which includes all the necessary components for containerization, which includes container runtimes and networking. When it comes to the different Docker components, I also mentioned images prior, which are the templates that are needed so that everything can run on the application, which includes the libraries, system tools, name it. And then we have the containers, which are instances of the Docker images that are runnable environments and encapsulate applications and their dependencies. And then we have volumes. So volumes are used for persistent data storage. They allow the data that is stored on containers to be shared and is persistent even if the container is destroyed. And then we have the network. So the networks allow the Docker containers to communicate easily with each other using the service name or the IP addresses. So Docker images still have layers. Layers are composed of changes which are persistent, or rather each layer represents a change which is made to a particular image. If you want to edit out an image, probably change the database that it's using or make modifications of how the file works. It acts as a layer in this case. And then the other thing is a Docker file, which is a set of instructions for building out the whole image. And then building images, I think every time you've worked with Docker, you've either seen Docker build or Docker compose build. And the differences actually between a Docker build and Docker compose is that Docker compose builds the services in the Docker. So in this case, if you have a database that's running, it's not really advised to run in a Kubernetes cluster, but you should actually incorporate things like NoSQL or Cloud SQL if you're using GKE. And another thing is, while Docker Compose builds the services in the Docker Compose.YAML file, the Docker builds is actually just building the image, which is illustrated on the Docker file. So right now, I'm also going to pivot to now the presentation part. Also need to install Docker, which is found in, I think, docker.com. You'll get to interact with how to download the Docker desktop application. So here is where everything or
Velda, I think we lost you. Uh, Velda, I believe we lost you.
Happens.
Velda, are you able to hear me?
The expensive particular application. The Docker
Hello, apologies for that. Our speaker is experiencing a few technical hitches, but she should be back with us. Unexpected blackout on her end, but she should be back with us. So let's just give her a few more minutes and then she will rejoin us. In the meantime, I will just be sharing her presentation from where she left off. Okay, we will give her a few more minutes as she tries to join back and continue from where she dropped off. So apologies for that unexpected technical, hitch on our end. Apologies again. This still has not yet been resolved. She's really trying to get back on the call. And for now, I guess we'll just admire her beautiful slides as we wait for her to come back. Yeah. Okay, seems the blackout has really had our speaker completely drop off, and we do not have a backup speaker. So we'll just give her a few more minutes. If she's not able to, you know, join back, then we may have to cancel the session for today, and then host her next week, hopefully when there's no blackout issues on her end. Um, so yes, so just give us a few more minutes as we work on getting her back. She's really trying to get connectivity. Um, going to be able to join us. So just give her a minute to just set up her hotspot, and then she's going to be joining us and continuing with where she left off. Okay, she is back. Yes. Hi.
Hi. I was talking to myself for a very long time. Then where did I leave it at?
Oh, you started a demo explaining Docker in in a more in-depth way, and that's where we lost you.
Oh, so I can just revert back to the particular demo. Okay, that sounds good. Let me just share my screen in a minute.
Okay. It happens. I can imagine you've been talking to yourself for more than 5 minutes.
Like I was, oh my god. Anyway, it is what it
Happen.
is. Yeah. Mm,
Yes. Okay. We are
oops.
waiting for your slides to come up.
Yeah. Hmm. I don't know. Can you? I can't see my slides yet. Let me. Yeah. What? No. Okay, got it. This is not what I need to present. Sorry. Yeah. Yeah.
Okay.
So,
Great. Velda, once again, we've lost you. I think feel free to kill video. Um, okay, yeah, back here. So I think this is where we lost you. You can make it a bit more
okay.
visible.
Okay.
Yeah, a bit more visible for the audience.
Alila, I don't know. I have set up my.
I don't know what's happening on your end, but we can hear you now. So feel free to. Okay, yeah, you can continue from there.
Okay, so as I was saying, like before you even start setting up the your Docker files, or rather to containerize, you need to ensure that you have a requirements.txt file which lists the dependencies you have. So you can either use the pip freeze command, pip freeze requirements.txt, and then have pip actually look for the dependencies and then create a file for you, or you could do it individually. I would prefer to still do it individually per every particular library you add, because then you know you won't miss some. Because once you start using pip freeze, then at some point you might also miss some of the packages that have been used. So the next thing is to add the Docker file. Just a second. So you should, all these files, you should actually add them on the root folder. Yes. So the Docker file now is a list of instructions of what your Docker image is going to be built up on. So in this case, it's a Python image, so it's obviously going to import from the Python version you're using. You could create your own directory, and then also now copy the requirements txt and then install that so that it's able to run on that particular environment. And then you could also choose what pod to use, and since when you're running Django applications, you use the Python manage.py run server. This is a command that you should actually have here so that it knows when it's starting up, this is the command to use. And then we also have the Docker compose YAML file, which lists the services that are going to be provided, because most of the times you're not just providing an application, but you also have a database. In this case, we're using Postgres, and then you also need to assign the different ports and the environment. In this case, you have to have the user, password, and the database name. And then to be able to run all this, as I said, you need to also have installed the Docker desktop application. And then when it comes to building, you could start by first building the application, which is a command I'm going to highlight here. So we're using Docker Compose, as I mentioned, because you're also having services like database. So we'll run this particular command, that is Docker Compose build, which now starts to build out how the image is going to look like, exporting the different layers and also naming the particular application. Once the build command has finished or has completed what it's supposed to do now, you'll now have to run the particular Docker Compose. But before then, if there are any packages or libraries you might miss, it's also going to come up here, because it's going to say that it does not recognize a particular file listed here. And then you Docker Compose app, which basically now starts running and attaching the particular database you have. And if there are also any issues at this particular point, it's going to show up here. And then also, while you're migrating, since you're moving the particular database you have to a different database, then you'll need to still run migration so that the Docker Compose app runs smoothly. In this case, you could have a different terminal where you actually do the migrations while Docker is still running, so that you can get all the information that you need. And then the other thing is we'll need to have now, since you have Docker installed, we'll have to go through. Yeah, as soon as your image is up and running, as soon as your image is up and running, we'll have to now particularly install. Uh, yes, as you can see here, I was running the particular command to migrate different databases. So after the migrations are running and everything is fine, then you could move on. And then the next thing is, if you want to see if the particular image has been created, you'll have the Docker images listed here, which is still another command. And then we have, if you also want to upload this to Docker Hub, which is the public repository for images, it's actually here. Um, just a second. Here. So this is the Docker Hub, which is basically the repository of different Docker images you have. And then you can either publicize or privatize them. But before you actually get to this point, you need to log in. You need to authorize. If you've already logged in into Docker desktop, then you're only going to authenticate with the existing credentials. You won't have to key in your username or password at this particular point. And then this docker ps command here is to basically list the particular images you have with IDs, that if you want to reference IDs while you're tagging the images. And then to be able to create a repository, then you need to tag the particular application you want to have. And then the username here, Velda, is actually the username on Docker Hub, so that you can slash the actual name of now the application you want to name it or use. In this case, I wanted to use API first swag hyphen web. And then once that's done, you can easily push, and then it's going to push with the latest tag, because you haven't written the version that you want it to be pushed to, or you haven't tagged it with the version that you want it to push to. And then once this is done, you can easily now view your image here. You can either choose to make this public or private, but in this case, this one is public. So I'll send it to Alila in just a few seconds so you could test it out if you want to. And this is actually the image that's running here on localhost. So the next thing we're going to look at is, I believe you can still see my screen and I'm still live.
Yes, you are,
The
and you
next
can
thing,
still.
okay, thank you for that. So the next thing is, what are some of the challenges that were brought about in regards to orchestration? So the first thing is there were deployment complexities, which was as a result of having a number of containers and microservices growing, which makes like manual deployment hectic and complex and also error prone. The next thing is scaling. When you're scaling containerized applications, then you must scale them horizontally, that is adding more instances, and also vertically, which increases the number of resources for individual machines. This can also be challenging if the particular containers are dynamically changing. The other issue is networking, where containers need to communicate with each other across different hosts. And to ensure this, you need to also have that was a key challenge for networking, because you need it to be secure, efficient, and also reliable, unlike my current internet. And then we have service discovery, which in a particular dynamic environment, you need to be able to discover different services which are needed to locate and also connect to the different instances of the particular service. And then the last thing when it comes to challenges is load balancing. You need to be able to distribute traffic evenly across or across multiple instances of a service to ensure that the services are available and are also performing optimally. And then the next thing you're going to look at is Kubernetes. So I believe most of you have either worked with or know about Kubernetes. So it's an open source container orchestration platform for automating deployment, scaling, and managing of containerized applications, which then came in to solve the issues that Docker had of deployment complexity, scaling, networking, service discovery, and load balancing. So a few functions about or key functions in regards to Kubernetes is orchestration. So it automates the deployment and scaling of containerized applications, which ensures that the desired number of container instances are running even in the face of failure. And then the other thing is service management. So Kubernetes provides a mechanism for exposing containers as services with automatic load balancing and DNS-based service discovery. So you don't have to really look for the services. It also helps you look for the services in this case. And then the next thing is scaling. So applications can be scaled manually or automatically based on the policies that you have that allow them to handle different workloads efficiently. And then there's also the concept of self-healing, which is automatically replacing or rescheduling containers that fail or become unresponsive. And then also in regards to rolling up updates, Kubernetes helps to roll back and also roll updates that are deployed with minimal disruption to the actual users of the service. And then concepts that you need to know when you're working with Kubernetes is pods. So pods are the smallest units, or the smallest deployable units in Kubernetes, and contain one or more containers that share the same network namespace and storage volumes. So the next thing we're going to look at is replication controllers. So this ensure that a specified number of production replicas or instances are running at all particular times. And if a pod fails, then they are terminated by the controller automatically, and the controller also replicates that particular pod. And then the services, they define a set of the pods that we just mentioned and provide a particular stable network endpoint to access them. And then the labels and selectors are just key value pairs or other dictionaries attached to the pods. And then the selectors are used to filter and organize resource based on the labels. And then the other thing is configuration maps and secrets. So the configuration maps are actually used to store configuration data, and then the secrets are used to store more sensitive information like API keys. So in this case, we're going to look at Google Kubernetes Engine, which is Kubernetes basically provided by Google in this case. And then it's a managed Kubernetes service offered by Google Cloud, and it has a couple of benefits, which is it handles the underlying infrastructure, which includes the control plane and the master nodes in this case, because all nodes need to have a master node which helps in running the services. And then you have in terms of scalability, GKE clusters are easily scaled to accommodate growing workloads, and users are able to remove or add nodes as they need. And then, in regards to integration, you can easily integrate Google Cloud services such as Google Cloud Storage, Cloud Logging, and also Cloud Monitoring. And also, in regards to security, Google provides automated patching and identity and access management integration, IAM. And then when it comes to monitoring and logging, GKE offers built-in monitoring and logging tools to help users understand the different performance and behaviors of the clusters and the different applications. That is to know when a particular cluster is performing well, or if there are any issues, or what needs to be done to increase performance. So there are many differences between Docker and Kubernetes, but the Docker is obviously helping in regards to containerizing in your particular images, and then Kubernetes basically runs the cluster and orchestrates one or more clusters in this case. So Docker focuses on container creation and packaging, while Kubernetes focuses on orchestrating containerized applications. And then the other thing is that these are the main differences. That is, the controller, the Docker enables container scaling but requires manual intervention, whereas the Kubernetes automates container scaling both based on the particular user-defined policies. And then Docker has basic orchestration features, but limited to complex applications. That is, you have a lot of services running. As I mentioned previously, you might have challenges. That is why you need to use Kubernetes. And then Kubernetes excels at managing multi-container applications, and you don't need to worry about whether it's security or performance, since you can easily integrate it with Google Cloud Logging and monitoring. And then Docker promotes portability by packaging the applications into containers, whereas Kubernetes enhances portability by managing the container deployments across different environments. So something I'd like to mention is, in this case, if you wanted to deploy this particular application, you would, if you're using GKE, that is, uh, you would have to use Cloud Shell, of course, if you've interacted with the Google Cloud platform. And then you have, oh yeah, so these are the different commands I'd like to list down before the call ends, or how you could easily host this particular service. So in the first command is to create the cluster. That is after you've configured Google Cloud here on Shell to have set to the project ID. My project ID here is the API first swag. And then here we have the Google Cloud container, which creates the cluster called cluster app WDA. Once the cluster is created, you now need to assign a region to that particular cluster. In this case, I used US Central 1A, which is the region actually close to me, which is in South Africa at this particular point. But it's not limited. You just use a particular region that is close to you because of performance issues as well. And then the other thing is, once this is done, it's going to provide you with the name, location, the master version, the IP, the particular node you're on, and the number of nodes provided. So my number of nodes is 3, but there's also a command that is --num nodes, which specifies the particular nodes you have. If you feel like 3 nodes is a lot, you could still minimize the particular nodes. And then when it comes to now looking at how to actually uh, look at the containers you have, you need to also get the credentials for the particular application you're running, and then also have the project listed, or whatever project you like to list in that particular zone. In this case, I chose the project name to be API first, and then told the G-Cloud container cluster to get the particular credentials. And then the other step was, we now want to create a particular deployment. I called it hello deployment. And then remember, we have the Docker image that we created and exposed it on the hub. So in this case, if you want to pull this image from Docker Hub to GKE, you'll have to just copy the particular name. The name of this image is Velda Kiara / API First Swag, I think, web. Yeah, this is the name. So this is how you pull the image. So you don't have to necessarily just you could either do it locally or still have it on Docker Hub. I preferred Docker Hub because it was easier. And then we now assign the type of load balancer and the type of port you want to use. And then once that is done, I think I had an error here which says it's not found, but then later on, after figuring out what went wrong, which is basically on this particular command, I had to now run it again, and then the particular deployment was exposed. To get the particular services, you could easily use kubectl get service. In this case, first of all, after you've created it, you'll have to wait for a couple of minutes, because then it's going to be pending. And then once you get the particular external IP, this is the external IP. So right now, apparently, I don't know why it's failing, but I think the issue is on ports. So I'd still have to edit this later on. But basically, that's how it works. You could also follow along this particular uh, quick lab, which helps you know how to containerize, or rather, not containerize, but put your cluster on GKE. It has a particular set of instructions, but since if you've already containerized the application, and it exists on your own Docker Hub, you can easily just figure out how to work with it from the image particular point, set the zone, but then you still have to create a Google Cloud account, obviously, so that you can use the service. And then you could easily start from this particular part, because then you've already Dockerized your application, and then come and add the particular cluster information here by pulling it from the Docker image. Most of this information is also online, so if you also want to deploy any other applications that not necessarily a Django application, you can easily do this. So I'll be sharing this and the link to the project I was working on, and hopefully I'll share this particular URL once I have fixed the issue. So I don't have any question, or I'd like to take questions now.
Okay. Thanks, Velda, for that amazing presentation. I guess we'll start with this question from Ahmad on when not to use Docker. And
Oh,
again,
yeah.
please feel free to drop your questions on the chat. We'll be highlighting them so that Velda can check them up.
When not to use Docker, it depends actually on what the services you're providing or not. Do they necessarily need to have different environments? For example, if you're working in a team, you might want to have particular services, and then you also don't want to have anybody having underlying issues, because most of the companies, actually, when you join most of the companies, most of them have like images, so that you don't have to worry about the different dependencies. Why is a particular application failing? I think it basically depends on the application you're working on, and also the scale, among other factors. The next
Okay.
question is, Actually
Thank you.
thought I was offline for a bit.
No, no,
Yeah,
no, no,
thank
no.
you for confirming that you're here.
Please feel free to drop your questions. I'm sure Velda is going to be happy to take them up. But compliments, there is, that was a great presentation. Lots of compliments on the chat, and people have joined from, across just to listen to you speaking about Docker and Kubernetes in general. Please, if you have questions, I think we still have a few more minutes, so she will be in a position to take them up. Um, okay, if there are none, Velda, would you kindly share the resources with me on the private chat so that I can share it with those who are tuning in?
Yeah, and also something to note, like some of the images might not work because of certain issues, but don't give up. All these things happen. Like my cluster has failed this particular minute and it was working, so I don't know what's going on. But then I'll still share it. Feel free to reach out to me on Twitter or LinkedIn. I still answer questions, and I'd also love to know how you either create clusters or whether there are also other different platforms that you use to create clusters. So yeah, thank you. And I hope you learned something.
Yes, I'm sure everyone learned something. I thought you said it works on all machines. Is it that moment where you're like, it
No,
was
it
working?
works. The process is it works. Like the Docker image actually works. If you clone the image right now and run it on your machine, it will run as is. But right now the issue is with this cluster because I think it was nice one. Ahmed. It works except on my machine. No, but now it works on all machines technically, but this particular cluster is not behaving. But I'll still also share the solution once I figure it out. But I think it's because of pods, because my Django application is running on different pods and the cluster also is running on different pods. So I have an idea, and you can easily access the Docker image, and then you can fight me after that if it doesn't work on your machine.
Okay, we will be sharing with you the Docker image, and then just feel free to let us know if it worked. Ping her if it does not work because she says it should be working on all machines.
Yeah.
A request from Sadiq is that you do a giveaway, but that is a story for another day. So thank you all for tuning in. This was our eighth episode of the Women Developer Academy series. We still have 13 more to go, with an amazing pool of speakers just coming on board to just share their insights on various topics. The way Velda has come to talk to us about containerization, Docker, Kubernetes, for us who had no idea even what orchestration was. So thank you so much. Velda, parting shot from you, and we will be looking forward to getting the resources that we could utilize to learn more later on the call. Thanks. Over to you,
Okay.
Velda, to call it a wrap.
My last parting shot is make it work. Regardless, make it work and keep pushing. And the resources, I'll share them with Alila first before I share them like publicly, so you'll have access to the resources.
Okay, thank you. Thank you all for tuning in, and we will now call it a wrap as we end our broadcast.